Hello everyone. So today I am going to start a new chapter, that is water. And today's class I will discuss unit 1, that is dissolution of salt in water. So before we know about dissolution, we need to be aware of some of the terms used in this case. First of all, solvent. What is a solvent? A liquid which dissolves other substances in it. Then we get solute, a substance which dissolves in a liquid. And then we get solution, product formed by dissolution of a solute in a solvent. Okay? So, in case the solute may be a solid substance, let it be a solid substance, and it will be dissolved in solvent, and so we will get our product as solution. Okay, another thing about solution, that is a solution should always be a homogeneous mixture. Okay, if a solution is not heterogeneous, then we cannot consider it as a solution. It will be a suspension. We will discuss about that thing. Solution should always be homogeneous. Remember this thing. So let's take an example. So I will take a beaker and I will add some water in it, and I will put some common salt in it. Okay, and then I will stir it, and after stirring I will notice that the common salt which I have put into water will disappear after some time. In case we will get the salt solution, we will get salt solution. In case the common salt which we have used is our solute, and this water we have used is our solvent, and we get the product, that is our solution. Okay, so the solute which dissolves in a liquid, and we get our solvent which dissolves the common salt in it, and the salt solution we have got, that is our solution. Got it? So there are some conditions for forming a solution. We will discuss about the conditions, that how a solution will form. For the formation of solution, first of all we need a solute, and then we need a solvent. The thing, for dissolving a salt or a substance solute in a solvent, we need to stir it. Then we need to specify that the temperature of the solvent is comparatively higher than the temperature of the solute. Temperature of solvent should be higher than solute. Okay, so now why temperature has to be greater than the solute? Why the temperature of the solvent has to be greater than the temperature of solute? It has a reason, and I will discuss about that thing. And the third thing we need to take care about, that the solute which we have taken, it should be finely powdered. Okay, if a solid thing, that is a solute, if we will grain it, then we will get the powder form. Now, why powder form we need? Because for dissolving a solute in a solvent, that particles has to be finely distributed so that it will form a homogeneous mixture. For that instance, we need to get the solute in powder form because it will get more capacity to be evenly distributed within the water or within any solvent. Now, why stirring and temperature determines the formation of solution? Why temperature and stirring determines the formation of solution? That have a logic. Suppose I will take a beaker and I take some water in it. Okay. Now I will add some common salt in it, that is NaCl. Okay, and we will get the product as salt solution. Okay. Now this NaCl we will easily get in powder form. So that condition is approved that we will get the solute in powdered form. Okay. Now, if we stir the solution after putting the NaCl in water, if we stir it, then it will increase the kinetic motion of NaCl particles. Kinetic energy. If we stir the common salt in water, then the kinetic energy of the common salt will definitely increase. And why increase in kinetic energy will help in the proper formation of a solution? Because if you consider the molecules of water in such way and you take the molecules of or the particles of common salt in such a way, you can see that after putting the common salt in water, it will not get distributed evenly for initially, but after stirring you will see that the common salt disappears. Why? Because you have stirred it and you have increased the kinetic energy of common salt. When you increase the kinetic energy of the common salt, the water molecules as well as the common salt molecules will be moving in a faster motion, and so the intermolecular space between these molecules will be more. Therefore, the common salt particles will get the capability to acquire the space between these intermolecular spaces. When you put the common salt in water and you stir it, you increases the kinetic energy of common salt. When you increases the kinetic energy of the common salt, then the water molecules as well as the common salt molecules will move faster, and the intermolecular spaces will change uniformly, and this may acquire the common salt between the intermolecular spaces of water. Okay, got it?